Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, we are going to continue with the moment area method. And the reason I'm using another example is to cover stuff that we haven't covered so far. So we are going to say in this problem, we want to find, excuse me, theta sub A, so the slope at A. Well, I don't think we need the slope at C, since we learned that all what you have to do is to add the area of the bending moment diagram. So let's say I want to find the deflection at C. Deflection at C. Location of delta max, the maximum deflection, where does it occur, and its magnitude. So we start the problem as before. We are going to find the reactions at the support so we can draw the bending moment diagram. So we see that I told you last time that it's a quick way to do it is to see if this ratio, like it's 2:1, so the concentrated load, which is the only load acting on the beam, will be split into 2:1. Of course, the closer, the higher, right? So 1 and 2 is 3. So 2/3 will go to C, 1/3 will go to A. 1/3 of 24 is 8. So that would be 8 kips. And this is 16 kip. The reason, as I said, this is a long example and I don't want to waste your time. That's why I didn't redraw the free body diagram and calculate, because as I said, it's not correct to show the support as well as the reaction, because in the support there are two forces, one acting on the beam and one acting on the soil, so, or the lower column or whatever is carrying the beam. But we do it for like quickness. Again, also, so we don't lose time. Let's draw. This thing would go something like that. The elastic curve. And if I want to calculate theta sub A, then I'm going to find, after drawing the bending moment diagram, this guy would be TC with respect to A. And then this would be theta sub A. And let's see what we get. Finally, we are going to draw the bending moment diagram. It's a positive moment. And we know it's PAB over L, but you can simply say 8 kips times 12 is 96. And of course, 16 times 6 is 96. So basically we have, if this is the bending moment diagram divided by EI, so that would be 96 foot. And this is the same, and this is bending moment diagram divided by EI. Okay. So now we say that in order to solve for theta sub A, I know the adjacent, I want the opposite, which is TC with respect to A. So we are taking the moment about C, okay? So if we say this is one triangle and this is a second, or you can do it once and for all, but let's play it safe. And we say, okay, the number one is has an area of 1/2 base times height. And the centroid here, if this is 12, it's B over 3 from this line, meaning it's 4 feet. 4 plus 6 is 10, so times 10. Plus 1/2 6 times 96. Oops. And now this is 2/3 from here, meaning this is 2 feet, and the distance from C is 4. Well, this is 6. 6 times 96 is 576, and you have a 0, and this is EI, of course, plus this is 3 and 12, right? 960 and 192, so that's what, 1152 or something. Let's do it. Okay, so 6t times 96, yeah, 57, plus 12 times 96, right? 69, 12. So yeah, 1152 as I said, but I wasn't 100% sure. Didn't get my coffee yet. No, I'm lying. I drank coffee. Okay, so now we have that. We can say theta sub A. I divide the opposite over the adjacent, which is 18. So that would be 6912 divided by 18 EI equals, so divide this by 18, I get 384 over EI. By the way, if we, but this, by the way, this is rotating clockwise, so that's negative, okay? I can find theta sub C since we are doing it, so we can see something else. Okay, even though they didn't ask us to find theta sub C, but it's easy. We can say theta sub C equals negative 384 over EI plus the area over EI. And the total area here is 1/2 base, which is 18, times height, which is 96, equals, so I get times -1, because that's a negative, plus 9 times 96, right? Which is 86. Okay, 9 times 96, 40. Okay, 96. So I get 480. 480 over EI. Okay. So that's the first answer. The second answer we want is to find delta C. Delta B. I'm sorry. That should be delta B, not C. C is 0. Delta C is 0. Delta B. You see that if I take this whole distance, or this distance from here to here, is basically TB with respect to A, correct? And the total distance is theta A times 12, 12 theta A, and that is delta B. So I can write an equation, very simple equation. I can say 12 theta sub A. I don't care about the negative sign. All the thing is saying but that distance is 12 times 384 over EI equals T B with respect to A that I will calculate plus delta B, which I'm looking for. Just, there is no reason. It's okay. So what is T B with respect to A? I'm going to take the moment only of the left-hand side with respect about B, right? We already noticed that this is 1/2 times 12 times 96 times 4, not 10. So it's 4/10 of that. So that equals 6 times 96 times, oops, or 24 times 96. It's easier, right? 2304. So now I can write the equation 12 times 384 over EI equals 2304 over EI, right? Because TB with respect to A, you divide by EI plus delta B. So delta B equals 12 times 384 minus 2304 is also 2304. Let's solve it from the right, okay? Because we know this is 480 EI, that's delta C. So if I draw something like that, this would be TB with respect to C, and 6 times theta C should equal TBC. So just to check our answer, oh my God, I said I have to throw this in the garbage so I don't pick it up error. TB with respect to C equals the area of that, which is 1/2 times 6 times 96 times 2. The 2 and the 2 cancel, and this would give me 576. So I can say 6 times 480 over EI, meaning 6 theta C. That will give me this height, No, I'm sorry. This will give me the whole height because I multiply theta sub C by 6. So it gives me that height minus or equals 576 over EI plus delta B. So that cannot be, could it? Yeah, maybe. 480 times 6 minus 576. Yeah, 2304. Okay, so the correct answer is 2304. Using this pen. 2304 over EI. And we have done something similar before, so really nothing new. The question now, where is the location of the maximum delta or deflection? If you think about it, the relationship between slope and deflection, go back a little bit to something we did before, is the same as the ratio of the shear force to the bending moment. Exactly the same. And how did we find out where is the location of the maximum moment? Yes, because the shear is what? Speak up, I couldn't hear. I want to cheat from you. Yes, it's the derivative of the bending moment, so it has to be 0 when you reach an extremum, right? A maximum or a minimum, exactly. So basically, we want the area under the curve, under the bending moment diagram, divided by EI to equal what? To equal theta A times X, if we call that distance X, or theta C times that. It's easier to work from A, right? Because you would say, and how do you know how do you know that it's between AB and not between BC? I said, I'm not going to answer that. You should know it by yourself. How? How would I know it? Tell me, how do you know it? Is there a way? If you want to find the the um, the slope at B, won't you add this area to the slope at C? The slope at A, I'm sorry, the slope at A is negative 384. And this area is 1/2 times 12 times 960. 6 times 960, which we already did here, and it was 576. Right? If you add 576 to negative 384, you will get a positive value, meaning I reached the 0 before reaching B. But that's not the issue. Let's say now that this area, first of all, the slope at A, so theta sub A equals negative 384 over EI plus over EI. What is this area? If I call this X, do you see that every time I move 1 unit, I go up 8 units because that reaction is 8 kip. So the equation of this line is 8x. So this area right here is x times 8x over 2. That will give me the area of the triangle. Correct? And now I equate that to 0. So I get 4x squared equals 384, which means x squared equals 64, like, or x, what am I saying? So 384, oops, where is the law? 384 divided by 4 is 96. So of course, x cannot be negative. So x equals root 96, square root of 96. And 96 is 16 times 6. So I can write it 4 root 6 feet. And that's the third answer. So far, so good. So now we found everything. Now, all what I have to do is to say, I'm going to do the same thing. I'm going to draw a line here at a distance that we say it's root 96, like 9 point something feet. And we say, okay, so if I multiply 4, 9, so if I write if I multiply the theta sub A times, so theta sub A, which is 384 over EI, I'm going to multiply it by 4 root 6, right? That will give me this whole distance from here to here. I also need to find TB with respect to A and then subtract it to get delta max. And let's call this point D, for example. So I said B, no, D. So equals TD with respect to A plus delta D, which is delta max. So let's find TD with respect to A. Well, to find that, I have to take this area, which I already know, and multiply it by x over 3. If this is x, the centroid of this triangle is at 1/3 of that line. Okay? So it equals first of all, we already know that this area is 384 over EI. There is no reason to write it again, but you can if you wish. But I think it's a waste of time because you are going to say this area is one half times x, which I'm going to replace by 4 root 6, by 8x, which is 8 times 4 root 6. But that equals this. So I say they are equal 0. So as a magnitude, that has to be 384 over EI, right? That's the whole area. And then multiply it by 4 root 6 over 3. So I'm going to leave the root 6 and I say, okay, if I take the 384 times 4/3, that will give me 512 root 6 over EI. And finally, delta D, the maximum D, would be 384 times 4 square root of 6 minus 512 square root of 6 equals 2508. Yeah, I mean, that's approximating. Or if we multiply by square root of 6, 6144 square root of 6 over EI. Okay, which is or 2508.28 over EI. Notice that the deflection at B was 2300 over EI. This is 2500. So it's makes sense, right? It's not like 15,000, right? It didn't make any sense. They have to be close to each other. This is 12 feet. This is 9.2, whatever. No, 9.6 or 7, right? What's the square root of that? Square root of 96, it's 98, roughly 9.8. So 9.8 and 12, we expect the deflection not to be far off from each other, right? And that's basically complete our coverage of the moment area method. I hope it was easy. Once we solve few examples, if you have any questions or comments, please don't hesitate to let me know, and I will get back to you as soon as I can. Thank you very much for your time. Hope to see you soon.